Mount Erebus. Mount Erebus is the second highest volcano in Antarctica and the southernmost active volcano on Earth. It is the sixth highest ultramountain on the continent. With a summit elevation of 3,794 meters, it is located in the Ross Dependency on Ross Island, which is also home to three inactive volcanoes, Mount Terror, Mount Bird, and Mount Terra Nova. The volcano has been active since about 1.3 million years ago and is the site of the Mount Erebus Volcano Observatory run by the New Mexico Institute of Mining and Technology. The volcano was the site of the Air New Zealand Flight 901 accident, which occurred in November 1979. Mount Erebus is currently the most active volcano in Antarctica and is the current eruptive zone of the Erebus hotspot. The summit contains a persistent convecting phonolithic lava lake, one of 5 long-lasting lava lakes on Earth. Characteristic eruptive activity consists of strombolian eruptions from the lava lake or from one of several subsidiary vents, all within the volcano's inner crater. The volcano is scientifically remarkable in that its relatively low-level and unusually persistent eruptive activity enables long-term volcanological study of a strombolian eruptive system very close to the active vents, a characteristic shared with only a few volcanoes on Earth, such as Stromboli in Italy. Scientific study of the volcano is also facilitated by its proximity to McMurdo Station and Scott Base, both sited on Ross Island around 35 kilometers away. Mount Erebus is classified as a polygenetic stratovolcano. The bottom half of the volcano is a shield and the top half is a stratocone. The composition of the current eruptive products of Erebus is an orthoclase porphyritic tephritic phonolite and phonolite, which are the bulk of exposed lava flow on the volcano. The oldest eruptive products consist of relatively undifferentiated and non-viscous bosonite lavas that form the low broad platform shield of Erebus. Slightly younger bosonite and phonotephrite lavas crop out on Fang Ridge, an eroded remnant of an early Erebus volcano, and at other isolated locations on the flanks of Erebus. Erebus is the world's only presently erupting phonolite volcano. Lava flows of more viscous phonotephrite and trachyte erupted after the bosonite. The upper slopes of Mount Erebus are dominated by steeply dipping tephritic phonolite lava flows with large-scale flow levees. A conspicuous break in slope around 3,200 MASL calls attention to a summit plateau representing a caldera. The summit caldera was created by an explosive V6 eruption that occurred 18,000 plus or minus 7,000 years ago. It is filled with small volume tephritic phonolite and phonolite lava flows. In the center of the summit caldera is a small, steep-sided cone composed primarily of decomposed lava bombs and a large deposit of anorthoclase crystals known as Erebus crystals. The active lava lake in this summit cone undergoes continuous degassing. Researchers spent more than 3 months during the 2007-08 field season installing an unusually dense array of seismometers around Mount Erebus to listen to waves of energy generated by small, controlled blasts from explosives they buried along its flanks and perimeter, and to record scattered seismic signals generated by lava lake eruptions and local ice quakes. By studying the refracted and scattered seismic waves, the scientists produced an image of the uppermost of the volcano to understand the geometry of its plumbing and how the magma rises to the lava lake. These results demonstrated a complex upper volcano conduit system with appreciable upper volcano magma storage to the northwest of the lava lake at depths hundreds of meters below the surface. Mt. Erebus is notable for its numerous ice fumaroles, ice towers that form around gases that escape from vents in the surface. The ice caves associated with the fumaroles are dark, in polar alpine environments starved in organics and with oxygenated hydrothermal circulation in highly reducing host rock. The life is sparse, mainly bacteria and fungi. This makes it of special interest for studying oligotrophs, organisms that can survive on minimal amounts of resources. The caves on Erebus are of special interest for astrobiology, as most surface caves are influenced by human activities, or by organics from the surface brought in by animals or groundwater. The caves at Erebus are at high altitude, yet accessible for study. Almost no chance exists of photosynthetic-based organics, or of animals in a food chain based on photosynthetic life, and no overlying soil to wash down into them. They are dynamic systems that collapse and rebuild, but persist over decades. The air inside the caves has 80 to 100% humidity, and up to 3% carbon dioxide, and some carbon monoxide and hydrogen, but almost no methane or hydrogen sulfide. Many of them are completely dark, so cannot support photosynthesis. Organics can only come from the atmosphere, or from ice algae that grow on the surface in summer, which may eventually find their way into the caves through burial and melting. As a result, most microorganisms there are chemolithotrophic, i.e. microbes that get all of their energy from chemical reactions with the rocks, and that do not depend on any other life forms to survive. The organisms survive using CO2 fixation, and some may use CO oxidization for the metabolism. The main types of microbe found there are chloroflexi and acidobacteria. Mount Erebus is large enough to have several named features on its slopes, including a number of craters and rock formations. Named craters located on Mount Erebus include Side Crater, a nearly circular crater named for its location on the side of the main summit cone, and Western Crater, named for the slope on which it sits. There are many rock formations on Mount Erebus. On the northwest upper slope of the active cone near a former exploration campsite, lava flow has formed a prominent outcropping called Nausea Knob, named for the nausea caused by elevation sickness. Also on the northwest slope sits Tar Nunatak, named by the New Zealand Geographic Board in 2000 after Sergeant L.W. Tar, an aircraft mechanic with the New Zealand contingent of the Commonwealth Trans-Antarctic Expedition. On the southwest rim of the summit caldera sits Seismic Bluff, named for a seismic station nearby. Mount Erebus was discovered on January 27, 1841, by polar explorer Sir James Clark Ross, who named it and its companion, Mount Terror, after his ships, Erebus and Terror. Present with Ross on the Erebus was the young Joseph Hooker, future president of the Royal Society and close friend of Charles Darwin. Erebus is a dark region in Hades in Greek mythology, personified as the ancient Greek primordial deity of darkness, the son of chaos. The mountain was surveyed in December 1912 by a science party from Robert Falcon Scott's Terra Nova expedition, who also collected geological samples. 2 of the campsites they used have been recognized for their historic significance. They have been designated historic sites or monuments following a proposal by the United Kingdom, New Zealand, and the United States to the Antarctic Treaty Consultative Meeting. Mount Erebus summit crater rim was first achieved by members of Sir Ernest Shackleton's party, Professor Edgeworth David, Sir Douglas Mawson, Dr. Alistair Mackay, Jameson Adams, Dr. Eric Marshall and Philip Brocklehurst, in 1908. Its first known solo ascent and the first winter ascent was accomplished by British mountaineer Roger Meare on June 7, 1985, a member of the In the Footsteps of Scott expedition. On January 1920, 1991, Charles J. Blackmer, an iron worker for many years at McMurdo Station in the South Pole, accomplished a solo ascent in about 17 hours completely unassisted, by snowmobile and on foot. In 1992, the inside of the volcano was explored by Dante I, an 8-legged tethered robotic explorer. Dante was designed to acquire gas samples from the magma lake inside the inner crater of Mount Erebus to understand the chemistry better through the use of the onboard gas chromatograph, as well as measuring the temperature inside the volcano and the radioactivity of the materials present in such volcanoes. Dante successfully scaled a significant portion of the crater before technical difficulties emerged with the fiber optic cable used for communications between the Walker and base station. Unfortunately, Dante I had not yet reached the bottom of the crater, so no data of volcanic significance was recorded. However, the expedition proved to be highly successful in terms of robotic and computer science, and was possibly the first expedition by a robotic platform to Antarctica. Air New Zealand Flight 901 was a scheduled sightseeing service from Auckland Airport in New Zealand to Antarctica and return with a scheduled stop at Christchurch Airport to refuel before returning to Auckland. The Air New Zealand flyover service, for the purposes of Antarctic sightseeing, was operated with McDonnell Douglas DC-1030 aircraft and began in February 1977. The flight crashed into Mount Erebus on November 28, 1979, killing all 257 people on board. Passenger photographs taken seconds before the collision removed all doubt of whiteout conditions or the flying in a cloud theory, showing perfectly clear visibility well beneath the cloud base, with landmarks 13 miles to the left and 10 miles to the right of the aircraft visible. Further investigation of the crash showed an Air New Zealand navigational error and a cover-up that resulted in about $100 million in lawsuits. Air New Zealand discontinued its flyovers of Antarctica. Its final flight was on February 17, 1980. During the Antarctic summer, snow melt on the flanks of Mount Erebus continually reveals debris from the crash. It is visible from the air. Topographic map of Ross Island from United States Geological Survey. Aerial view of Mount Erebus craters. Satellite picture of Mount Erebus showing glow from its persistent lava lake. Mount Erebus in December 1955. Mount Erebus travel guide from Wikivoyage.